The Docker. What is Docker? Why do we need Docker? Where do we use it? Right? What are the differences between like a containerization and deploying an application as a standalone application? Let's look into all of these things. So before we get into this, let us take a use case to understand this better. Let us assume the scenario is like there is an application. Okay. Uh, and this application has got some requirement. It needs Ubuntu 16 and it has to have Java 17 and Tomcat 9. So there is an application, let's assume it's a gaming application developed by some company, and to run this application, these are the prerequisites for the application. And there are so many clients who are interested to buy this app, to use this app. Client 1, 2, and 3. There are different clients who are interested. Client 1 has got the Windows operating system and no Tomcat and no Java. Client 2 has got some, um, let's say, some Red Hat operating system, Java 17, and Tomcat 9, whatever. And this third one has got all the prerequisites. So, how do you provide application for these clients? Like for client 3, it's very easy to provide the application, right? But how about client 1 and client 2? Is it that you provide application for only those who have the required operating systems? Would you lose other clients, client 1 and client 2? If that is the case, business doesn't work that way, right? Like whoever interested, we should be able to provide them with the app. So how do we provide the application to client 1 and client 2? What are the solutions? Like what are the alternatives, options? How do we provide them with the app? Any inputs from your end? Like there are multiple solutions to this problem statement. One is through virtual machine, right? Like create a virtual machine, with Ubuntu 17 Java, Ubuntu 16 Java 17 and Tomcat 9 and share the VM so that those clients, whoever doesn't have the required operating system, can use it and run their application. So that is the one thing you can do, right? The other thing is like there is a similar solution for this problem statement, which is almost similar to VMs. Okay, Annabalgan says the app should be compatible for all OS. App may not be sometimes compatible, right? It might have got its own prerequisites. So one of the ways is to provide the VMs. Other way is you may go to their place, right? Update their operating system, change their operating system, but not that everyone would be interested for it, right? Because they might have other applications running. So not everyone would be interested to change their operating systems to run this app, right? So virtual machine is one of the option. Like we can create a VM and share the VM, right? Like in our Devops case, we did. Rather than modifying or changing, we can use a VM and share the VM. The other solution for the same problem statement is containers, right? What are containers? Just for now, understand something similar to VMs. Like you create a VM and share the VM, you can create a container, right? Both does the same, both solves the same problem, and both uses the concept of virtualization. Both uses the same concept, but in VMs, virtualization is done at the hardware, whereas in containers, virtualization is done at the OS level. That is the difference. Again, you might be having a question, what is meant by virtualization done to OS level? We will learn this. And this kind of virtualization happening at the OS level is called containerization. This is called containerization. And like virtualization happening at the OS level is called containerization. And how do you achieve this containerization? So there were tools like a Docker, which uses this containerization concept. Docker, right? This is a tool. Docker is a software or a tool which provides containerization platform. Means if you want to create containers or if you want to run containers, that's where Docker comes in. Means a Docker engine would be running. You will install Docker and start Docker there. So it's a software or a tool which provides containerization platform. There are other tools as such which provides a containerized environment. Other tools are like Rocket, LXC containers, and so on. But out of all of this, Docker is very famous and very widely used. Almost 98% it is Docker. Right? That's a container runtime. Right? So now, okay, we understood, okay, containers are something similar to virtual machines. They provide this containerization. And one more thing, containers are not replacing VMs or virtualization. It is just next level to virtualization. But what is meant by virtualization happening at the hardware? What is meant by virtualization happening at the OS level? When we should go for containers, when we should use VMs, right? What are the performance differences, architectural differences? All of them will be understood with the architectural diagram. Good to proceed, or any questions in this part? And by the way, so how was this solution solved? Create a container. This container will have Ubuntu 16, Java 17, Tomcat 9. Share the container with the client so that we will not lose the clients. Will provide our app will be running inside the container. We'll share the application as a containerized one, so it comes along with the dependencies means these are the dependencies. So you bind the application along with the dependencies. This is your container, and share the container like for those whoever are interested. Am I good? If that is good, like that's clear, let's get started with the architecture differences. Like what are VMs, what are containers, when we should go for it, and all. This architectural diagram will help you understand the things thoroughly. So first, let's talk about VMs. We already learned a little bit about virtualization, right? This is your infra, like your laptop. Okay, on that you'll have the operating system. Like let's take my laptop. Let's say I have Windows 11 or whatever, um, or any operating system, and then hypervisor. Hypervisor is a software, right? It is a software with which you can create your VMs, with which you can launch your VMs, allocate resources to your VMs, like VMware, Oracle VirtualBox, and so on. That's your hypervisor software. On top of it, you have some VMs. These are the virtual machines. Virtual machine 1, 2, and 3. These are the different virtual machines. Like, of course, how many you run and all different things, but if you see the VM, it will have its own operating system called as guest operating system. This is the host operating system, the main operating system, on which you can have a VM with its own operating system, which is called as guest operating system. Because it is having its own operating system, it just works like a normal machine. It can shut down, it can boot, it just works like a normal machine. On that machine you will have your application, like the application we are talking about, the gaming application or whatever it is. On top of it you will run your application, and the binaries and the libraries, these are nothing but the dependencies of the app, like Ubuntu, sorry, like Tomcat, Java, and all. This is the operating system. On top of it, the dependencies needed for the application. So it just looks like a normal machine, and because it has got its own operating systems, it is a huge, heavy, it takes time to start. They are slow, heavy, consume more resources because they have their own operating system. Let's say from the OS you need to allocate, let's say I have allocated 20 GB to this Okay, 15 GB to this and 10 GB to this. Out of this, majority of it, 8 GB might be consumed by the OS, 2 GB by the app. Here almost 12 GB by the OS and 3 GB by the app. So majority of the resources will be consumed by the operating system itself, right? So if you want to put too many VMs, your OS should have those many resources. Here how much we allocated? 30, 45 GB. Let's say I have only 50 GB. I have almost allocated 45 GB. 55 GB should be at least there for its own process to run. If you create another VM for that 5 GB, performance degrades. VMs works very slowly, right? You can't start them. You will see the performance degrade, right? So these are all the problems with the virtual machines, and that's how VMs work. And a very important point to note, you might have noticed to run these VMs, your hardware should support it. Means you should go to the BIOS and enable the virtualization technology. There is something called VT in the BIOS. You need to enable it. Of course, it comes by default enabling this option. If not, you have to enable it. Then only it will work. Means virtualization, your hardware should support this virtualization. That's why it's called virtualization is happening at the hardware. Is this much clearer understood? So this is about virtual machines. Now let's talk about containers. Again, the infrastructure, let's say I'll talk about my laptop. On that, you'll have some operating system. Earlier, Docker is natively developed only for Linux operating systems, but now we have Docker for our operating systems of Windows as well. From Windows 10 and above, we have Docker. Okay, so yes, it could be any operating system. On top of it, you will install Docker engine. Means Docker daemon is running, Docker engine, Docker is installed and Docker is running. Okay, this is your Docker, and top of it, you will have the containers. This is your container. Container will be having the application, the binaries, and the libraries. Means container, as the name says, it's a holder, it's a package which will have its own, its application and the dependencies of the application. That's all, nothing else, nothing more. That's all. Application and its own dependencies. If you see this particular part of guest operating system, like its own operating system is missing, means containers will not have its own operating system. They'll not have their own operating system. Operating system is missing, but they can work like a normal machine. Again, they just work almost similar. But how it will work? They will use the operating system of the host. They will share the kernel of the host. Right? So by not having their own operating system, they consume less resources. The main benefit. Okay, they are very fast because they don't have their own operating system. They can work really faster. They can be created very quickly, right? They are lightweight. Because they are lightweight, they run faster. They can be created on the fly and destroyed on the fly. So if you have limitations on resources, if you have limited resources or if you have some constraints, restrictions on the resources, better you go for containers. And like if you want to automate something quickly, containers. Right? And so that's how you have your containers, which are lightweight and which doesn't have their own operating system. So as the name says, it's like a holder. Your application should be packed along with binaries. Okay, we understood it consumes less resources. They are faster, they are lightweight, they can be created on the fly. Any other advantage apart from this? Yesterday, this is how we installed our application. This is an EC2 instance. On this EC2 instance, I installed Java 17, Maven, and then Git, and then I run MVN compile. You might have noticed for certain versions of Java, compile may be working, but package is not working. Have you noticed this? But if you put Java different version, it will work. Right? I told you like it's a version, it's a compatibility with your plugins, Maven plugins used and the Java version installed. So some goals might be working, some of them will not because of this compatibility issues. So what you have to do, you have to go here, install the right version of it. Okay, fine. I'll install the right version of Java and see that all the goals are executed. But let's say some upgrades, some patches may happen. This may not work. I mean, this might have upgraded or downgraded, and a version might have changed or corrupted. So again, you will not this package will not work, right? Also, you might have seen this in real world. Application works in dev environment, but it doesn't work in test environment. You know the like a chaos at that point of time, you need to first troubleshoot, identify the issue, fix the issue. If it is Java issue, you have to identify it, like troubleshoot, identify, fix it, and see the application is running. Correct? These are all the problems we have because of the compatibility issues or environmental issues. These are overcome by Docker because Docker is just a container which comes along with the application binaries. This is coming along with its own version of Java, right version of Java, right version of Maven. So you run this application on any server, be it a test server, prod server, integration server. Irrespective of the environment, it works seamlessly on any server because your container is having all the dependencies it needs for the application, right? So that is another major problem which Docker solves. Environmental issues or compatibility issues. So earlier, this is one thing. And earlier in the traditional approach, developers used to share that var file to ops teams. In the beginning of our intro, we learned, right? Developers will share. Do you all remember this? If you don't remember, I can take a step back explaining this. That's the reason I asked, but I'm not seeing any response. I don't know if anyone are there in the class or not. Developers will build this WAR file and they'll share this to ops teams. Ops teams have to struggle with underlying dependencies even though developers share the instruction document. This instruction document may not be working sometimes. Sometimes it might be working on Windows, it might not be working on Linux. They have to see that it's compatible, it's running. All of this would take time and deployment becomes slower. But now, developers will not share the WAR file. Developers will share the container. DevOps teams will have to run this on different environments like a test prod. It works seamlessly in any environment. They need not struggle for the underlying dependencies and compatibilities. Meaning in our lab also, we don't need to do this because application is not deployed this way. We don't run ambient package command like this. Rather, we containerize those packaging, deployments, and so on. It could be about MVN package, it could be about running it in the Tomcat, it could be anything. Am I making sense? That's how containers revolutionize the way of development and way of deployment as well. Means developers are not just sharing the WAR file, they know how to containerize it as well. This is another reason why I told even developers, let's say you want to continue as a developer, you don't want to become a DevOps engineer, you want to become, I mean, you want to continue as a tester, still you have to learn it because the way you share the application got changed. Some of the companies still that might be handled by DevOps team itself. They will containerize it, but in some projects, developers will do it because they have that knowledge. It depends on if the developers are equipped with those skills. Yes, they were doing it. Or in some companies, they were only preferring developers with those knowledge of containerization. So it all depends. But yes, when your application is shared in the form of container, definitely everyone should know how it is happening, and you should be taking, I mean, developers should be taking ownership of containerizing their application. Then share it to DevOps team. DevOps team will be responsible for running it, um, and providing access for it, seeing that it's running successfully, and so on. Understood? So these are the containers, three containers. If this much is clear, I'll proceed. These are the, like, this is the architectural difference and performance differences. Like, containers can perform well, they'll consume less resources and work faster. And here the main point to note is, to run these containers, your hardware need not support. You don't need to enable that virtualization technology in the BIOS. Meaning here, containerization is happening at the OS level, not at the hardware level. And this virtualization happening at the OS level is called containerization. Now this statement is justified. Is this much clear, everyone? Any questions from anyone? Any confusions? If clear, let me know. Please confirm. If anyone is listening, please confirm. If not clear also, you could tell the same if it is not clear. Sorry, I see a hand raise. Yes, Rajendra. I see a question. In single container, can we configure many pods, or a single pod can be configured? Yeah, I have allowed you to speak. You can. And what is meant by pod?
That ma'am, that services actually.
That is a
Services.
pod is a service, you mean?
Yes.
Pod is a totally different concept, and it comes in Kubernetes. We don't have pod concept here as of now.
Oh, okay.
Once we start Kubernetes, I'll talk about pods. It is not a service. It's a basic unit of deployment in Kubernetes. Okay, so I think this much is clear for all of you. So coming to these things, like your containers, one second. Huh. Now I have a question for you. Let's suppose I'm running a VMs. Okay, why do you need still VM when you have container roles? I'll come to that. First, let me ask you a question. Let's suppose this is my Windows. Can I run a Red Hat VM or Ubuntu? And can I run some other version of Windows? Are all of these three possible or not? Possible, because it's having its own operating system. The guest operating system is irrespective of the host operating system. Okay, now come to this part. Okay, this is my Windows 11, let's say. Can I have the same containers? Red Hat container, Ubuntu container, some other version of Windows. Possible or not? Possible. Firstly, you should have a question. I told containers will not have their own operating system. How come I say Red Hat container, Ubuntu container and all? That should be your first question, right? So how come we say Red Hat and so on? Yes, they will not have their own operating system, but they'll have the binaries of the operating system. Means, let's say, minimal OS, not the full-fledged OS, but just the minimal OS, just the binaries and libraries of the OS. Okay. So now answer the question. So it is Windows. Can I have all of this? Let's suppose this is my Windows 11. Okay, this is Windows 11. This is Red Hat, another distribution. This is Ubuntu, another distribution. This is Windows 22. Uh, Only this is possible. Windows 22 possible. Red Hat is a Linux, a different distribution. Distributions in Linux are like versions in Windows. So these are not possible because a Linux container cannot share the kernel of Windows. I told you they'll share the kernel of it. Whereas any Windows, any version is fine. They can share the kernel of this. That is the problem. You cannot run containers of different operating system. It should be same OS. The base should be same. Versions could be different. Understood? This is not possible. Let's say this is my laptop. I install Docker here. I can run only Windows containers. Any distribution, I mean any version of Windows is fine. Only Windows. Right? But what if I want to run Linux containers? I should have another Linux VM on top of it. Linux VM. Install Docker here. On top of it, you can run Linux containers. And the machine where Docker is installed and running is called Docker host. This is the Docker host for these containers. For these containers, this is the Docker host for them, Windows machine. And this is the Docker host for these Linux containers. They will share this kernel. Understood? The host should be the same operating system of the containers. Got it now? So this is how it works. Your operating system should be compatible, means you can run the containers of the same operating system. Whereas in VMs, that's not the case. You can run anything. Also, like I told you, container is just like an application. It's a package. Application is packed along with the binaries and libraries. So you should run those containers on some virtual machine or some servers. That's where still virtual machines are in place. But let's say assume I want to run we have address book application, right? Let's suppose I want to run 100 instances of address book. In VMs, you will be starting 100 VMs, right? And start address book. But with containers, I may just need one VM or two. Exact number, I'm not telling because containers also consume some resources. But containers consume the resources dynamically. You don't have to allocate the resources beforehand. Like for VMs, you should allocate some resources when you create it, right? But for containers, containers will consume the resources dynamically. You don't have to allocate them beforehand. They consume the resources dynamically. How many containers on a VM? It depends on their size. So, for example, I'm saying if you have like 100 containers, you want to run 100 instances of address book, you may just need one or two VMs. For example, I'm saying. So, VMs are costly. VMs creation takes some time. Maintenance management would be a challenge here. So, you just need two VMs on which you can run 100 instances of address book. That is the difference. That's how they save the resources. Right? You don't have to allocate the resources beforehand, but you can put a limit on how much resources they're consuming. You can put a threshold or a limit on how much resources they'll consume. Understood and clear? For Docker, it's possible it will create containers or different OS. No, it's not possible, Sarangi. So this is the theoretical part of Docker. We'll see like use cases and few more things. This is the architectural performance differences. Hope this is all clear for you. And see the differences, work scope. If you want to run multiple applications, maybe I want to deploy a database, address book application, I want to run some other services, better you go for a VM, like a multiple application. If you want to run multiple instances of the same application, like address book 100 instances, so better you go for container. Always the best practice is one service or one application per container is the best practice. You can put multiple also, but the best practice is one app or one service per container, so that it would be faster and it would be like that helps us, that provides us with more benefits. And coming to the portability, working with the VMs are platform independent. Platform independent meaning like we just discussed, you can have a VM of any operating system. Working with containers is platform dependent, right? You should choose the platform. Like if it is Windows, if your host is Windows, you can run only Windows containers. If the host is Linux, you can run only Linux containers. Okay, we'll talk about them a little bit. VMs consume more resources, whereas not containers. And you don't need a root privileges to run the VMs. Again, that's not the case with the containers. Understood and clear? So if then yeah, development with Docker. Build once, run anywhere. They're bothered about building the containers with the code, libraries, apps, data, and dependencies. Developers will pack the application along with everything it needs, and that's how they share the application. Deployment with Docker. Create once and run anywhere. They're bothered about running the containers, access, networks, everything. Once you share the container, DevOps team will take care of running it on different environments seamlessly. This is what environmental issues I'm talking about. It would be working on developers' machine but not on other machines. So how is it issue resolved? Actually, they'll spend some sleepless nights, troubleshoot the issue, identify the issue, fix it, and there is no guarantee it is fixed for lifetime, right? It may be surfacing again during patches, upgrades, and so on. And here, if you see, okay, before going there, so were all the use cases clear why you should go for Docker? If it is clear, we'll get into the actual Docker components. Right. So till now we were talking about containers, right? You create a container, share the container, and so on. Actually, like how is your container? How is it created? Do you share the container actually? Actually, we share the Docker image. Container is a running instance of the image. Running instance of the image. And actually, till now, I'm talking about we share the container, right? It's a running instance. It's like a imagine a virtual machine means it is running, right? You don't share the VM. If you remember earlier, also, you don't share the VM. There'll be some static file like a VMX file or OVA file by running which you will get a VM. So, if you want to share it with others, you would share this VMX file or OVA file, correct? By running it, they'll start a VM. Same is the case here. Actually, we share the image. Image is the static read-only file. By running it, you get a container. So static read-only file. This is the one we share it. Developers will share the image, not actually the container. By running it, we'll get a container. So container is the running instance of the image. Docker image, that's called Docker image. And by running it, you get a container. So, okay, fine, this is how it is. But where are those images stored? Those images stored on in a service called registry. Images are stored in a service called registry is a service where Docker images are stored. There are different ways the image can be stored. Here it will be stored in the Docker Hub. Docker Hub is a storage place of images, right? This is the storage place of images, the public registry. Of course, how we can store enterprise application, we'll see. But just let me tell you, yes, images are stored in a service called registry. Docker Hub is the default public registry where all images are shared. Means there was already pre-built images available for every version, every operating system, every software and all of those images are on Docker Hub. You share the image, you can share the image across the teams, run it to create a container. Right? See, images are stored here. Other teams can download the image from here and use it. Maybe for production server or staging environment and all. Or else if you want, you can start it and create a container. All of this is happening on some virtual machine, on some server. This is all happening on some server. Right? So Docker image, Docker container, Docker hub, a storage for images. Okay, but let's say I want to deploy my own address book application or enterprise level applications. So will those be available on public Docker Hub? Definitely no, you have to create it. Means you have to create your own images there. So how do you create those? From something called Docker file. Docker file is the basic unit from which an image is created. Either it is your enterprise application or either it is the built-in images available. Everything is developed in the same way. But the images stored in or whichever already created, those are also created from Docker files only, but that is managed and maintained by Docker. Okay, Docker file is the basic unit from which by building which you get a image. You build it, you get an image. Docker file is a text file with all the instructions written. And you build it, you get an image. You run it, you get a container. What is inside it? What are those Docker instructions? How to write it? All of them we are going to learn. We will learn thoroughly about Docker. With the content I'm covering in Docker, you can clear any sort of interviews and work comfortably, provided you do the hands-on, you provide your attention here. Okay, so these are the things: image, Docker file, Docker container, Docker hub. See here, the diagram also shows the same. This is the Docker file from which you get an image. You start it and you get a create container, or you can also store it on hub and share it with others. And image is a static read-only file, right? You can run the same image any number of times. If you want to run 10 instances of your address book, you will create an image for address book, one image for address book. If you run it twice, you will get two containers, thrice, three containers, and so on. Replicas are multiple copies, whatever you call, multiple instances of your application from the same image. Right? So just this is all theoretical part. We will see all of these things practically in some time. So that's all some understanding before we get on to the hands-on. And yeah, this is the formula you have to remember throughout your hands-on. Like build a Docker file, create an image. Run the image, you get a container. How do you run an image? How do you build it? What happens at the backend when you build it? What happens when you run it? All of that we'll see. And you can see container is compared with something in the transportation world. Like it's a container where you pack everything and ship it. Right, this is your Docker file where you write your Docker instructions and the Docker image and the Docker container. And the Docker image, what is present inside the Docker image, all of that base image, all of this in the hands-on. Container, it's a package with everything required to make software run except the operating system makes the application portable. And this is the architecture, like the host registry will come to the smart connection modes. Before that, this is one thing I would like to go with. See, Docker is a tool which provides containerization platform and helps in running containers. That's what we learned. It helps developers to pack the code along with its dependencies and ship it as a package. It ensures our application works seamlessly in any environment. Because it's coming up with its dependencies, it can work seamlessly in any environment. You don't need to struggle with the underlying dependencies on the compatibilities. Differences, deployment with Docker, environmental issues, Docker components. So architecture will come once we get started with the hands-on. So let's get started with the hands-on. Good to go. Let us install Docker and get started with the hands-on. You can use one more thing. You can use the same EC2 instance, whichever you are using till now, like the Jenkins one. You can use the same, or you can use your own laptop as well. Like I told you, Docker is natively for developed for Linux, but now it's used for Windows also. From Windows 10 and above, you have Docker. So if you are having Windows 10 or above, you can use Docker there. I will show you different ways of doing it. Before I show it on our EC2 instance, let me tell you, like this is for Linux system. So if you have any Linux system, you can install Docker. Okay, but for Windows, actually it's not for Windows, but yes, from Windows 10 and above, you can have it. You can have it on Windows 10, Mac. These are not supported ones. But now, yes, you can install Docker on these systems with something called Docker Desktop. Okay, listen carefully here. So you will install Docker Desktop. Here you will install Docker directly. And let's suppose you install Docker here. Can you run Linux containers, or which containers you will be running on EC2, Amazon Linux 2, sorry, Amazon 2 instances? You don't know which instances, I mean, which containers you can run, right? Yeah. So this is EC2 instance. It's an Amazon Linux 2 instance. So if I install Docker here, which kind of containers I can run? I can run Windows containers or Linux containers. First, let me install Docker here. Linux only I can run, right? We'll see. I'm install Docker. I'm install Docker will do. Docker is installed and Docker is running. I'll come to this compatibility issue in some time, whether Linux or Windows. First, let me show you one simple demo. Uh, so now this is the Docker host. Okay, Docker host means instance where Docker is running. It's a EC2 instance. a Linux instance, Docker is running, I can run the first basic command, Docker images. Docker images will list all the images present on this Docker host. Because it's a new one, I don't have any image. Okay, fine. I will run a sample. Hello world is a sample image. If you run this, if your installation is working fine, to test that, we'll run this basic image. So Docker run hello world, but hello world image is not there on my system. What happens now? It's not there on my Docker host, but I'm trying to run some image which is not there on Docker host. What happens now? Let's see. Generally, whenever you run an image, container should be created. Okay, also unable to find this image, hello world latest. You can't find this image locally, so it is pulling from the hello world, pulling from this hub and the pull complete, and it's showing this message like hello from Docker. It is displaying some welcome message. It means that, see, if you are seeing this message, means your Docker is installed successfully, it's working fine. This is where Docker daemon is running, Docker engine is running. It has searched something locally. If it is not found, it's pulling from Docker Hub, the default registry. What is your Docker Hub? Go to hub.docker.com. This is your Docker Hub. You may create a free account, or without free account also you can use it. You need a free account to push actually. If you want to store your images, you need it. So that is my username, Devops trainer. Okay, let's talk about this later. First, yeah, here is the hello world image. If it is not there locally, it will search on Hub and it will download. See, Docker official images means maintained and managed by Docker. That's what I told, like built in available images already. This is the number of pulls, number of stars, last updated date, so that you get all these details. It's an official image. This badge indicates it's officially maintained and managed by Docker. And if you just go, it shows a minimal dockerization, means an example, you can see if it's running fine or not, and it supports Linux and all of these servers. It says like it will show you all these details, whatever this image does and all. But so the whole point I want to show here is, if this image is not there, it will pull from the hub and it will use it. But what happens at the backend when you run? Yes, the image is pulled. Earlier the list was empty, but now you can see the image in your system, and it might have created a container. All the running containers can be seen with Docker PS. It's not there. Let me see all containers. Mine is a include stopped also. Yes, it started a container. Every container will have some container ID which is alphanumeric, the image from which it is created, and it is stopped. It is exited. And because it's difficult to memorize this alphanumeric, a random name is also assigned to the container, and this is assigned by Docker daemon. Okay, priceless Hamilton. So one image and it started a container but stopped. What if I run the same image again? You will not see it is pulling from hub. You don't see that message like earlier, right? Earlier you are seeing it unable to find this image, but now you don't see it because image is available locally. So image would be the same. But now if you see the container, see another container started 7 seconds ago, FO3 and all, and the name is determined roads, and it got stopped again. Right, like I told you some time back, you may run the same image any number of times, so those many number of containers will be created with a random names assigned. But if you want to assign your own name to container, yes, you can use name flag and give the name. I'm giving a C1, so that it will start another new container, but this time it will have its own name but not the name assigned by Docker daemon. Right? So three replicas of hello world images created. Okay. So like how it works and all we'll see. So this is called your Docker host or Docker daemon, the engine where Docker is running. And this terminal, where you are running these Docker commands are called Docker client. Docker client is a way to communicate with your Docker. See, Docker client is like a terminal where you run all your commands, build command, pull command, run command, all of them will learn. Those commands will go to the Docker daemon, means Docker engine on the Docker host. And this Docker host will connect with the registry if required, pull the images and does all of these tasks. See here, this Docker daemon is going to the registry, pulling those images and all, or built in the local images. And this registry is the default component. Docker Hub or is the default registry in the Docker architecture. So you don't need to do anything for them to communicate. They'll be communicating via REST API and HTTPS protocol. That's why you don't need to wonder how come it's connecting to Docker registry, Docker Hub. Docker Hub is the default registry. They can communicate by default. You don't need to do anything for them to communicate, is what I am trying to clear. Simple architecture. Docker host is nothing but your machine where Docker engine, Docker daemon is running. And the client is not like your terminal where you write the commands, and those commands, whenever you run any Docker commands, they go to the Docker host. So that's how communication happens with the Docker host, and it will pull the images and place them. Okay, and then the registry. So these are the three different components in the Docker architecture. In our case, Docker client and Docker host are on the same machine. You may connect to remote Docker host also. Your Docker may be running on some other machine. You may connect from some other remote machine also by running the commands. So that's how you can have Docker client and host on different machines. That's a simple different components. Any questions in this part from anyone? So, and by the way, if you see, I can run hello world, or else there is something else called Ubuntu image. Okay, see Ubuntu, it's not fine locally, it's pulling from the hub. You can go and search here for Ubuntu or anything. Right, those are all Linux images we are able to run. See, Debian based Linux operating system, a free Ubuntu image, so many are available. Okay, so because it's a Linux, I can run all Linux containers. Let us search for some Windows images. Windows inside a Docker container. Maybe let me try pulling this. Okay, command also given. Let me run this. Maybe it was not a Windows one. Minute. Hmm. See here. Manifest for Calico not found, manifest unknown. Right? So, like if it is a Windows one, you cannot run them on your Linux host. Okay, if they are based out of Windows, you cannot run them. Let's say if I want a Windows, what I should do? I should go for something like a Windows one, right? Like if you have Windows operating system, install Docker there. Let's assume yes, mine is Windows. Of course, it's Mac, but for Mac or Windows, it's the same. So let me go to my local computer, my laptop. Assume this is Windows, Mac or Windows, it would be similar. Okay. So yes, I have Docker desktop installed here. Install Docker desktop if it is Windows or Mac. How do you install Docker desktop? You have to download the widget and run it if it is Windows. Docker desktop. Okay, here install Docker desktop on Windows, Mac also it's there, but let's say if you go for Mac, okay, this is where you can choose and install it. The whole point is, okay, I have installed Docker desktop. I'll start it. How do you start it? You have it installed as an application. And this is where it is installed. This one. Double click. This is for Windows or Mac. Okay, see here, Docker is getting started. Docker desktop has got this user interface. You will see all the images, containers list here, but this UI is very rarely used. Only I will start here and I'll run the terminal only. Or else you may run from the UI also. So now I can run the images, commands, anything on my laptop. So here if I see Docker images, I can see the list of the images, right? Now, can I run Windows containers here? Let's assume it's a Windows laptop. Can I run Windows containers here? Docker pull will just download the image. It will not start any container from it. Here, can I run Windows? Pull means just download. Calico Windows is what I saw, right? Why you can't run here? When you install it with a desktop, okay, installed it with a desktop, right? Docker desktop. When we installed, it's not working. It's okay. So when you install it with a desktop, it will be coming with two hosts. Linux host at the backend and the Windows host means it will be running on the backend on a Linux, on a little Linux VM at the backend. Your Docker desktop will not be running on your OS directly. It will be using its own little Linux VM at the backend. And by default, it will use Linux VM only. That's why you can run Linux containers only. But it will have an option to switch. You can switch to Windows if you want. Then you can run Windows containers. That option is available with a Docker desktop. Switch the host option is there. Otherwise, it will use. Hmm, yeah, switching between Docker desktop. There should be some option available. You can make the switch. How do you make the switch here in this Docker desktop? If you go to the settings, because it's Mac, it will not show for me. But for if it is Windows, it will give you an option here to use Linux host or Windows host. So accordingly, you can switch. If you don't use the switch, see Docker Linux, it will use the default one as Linux only. That's why you can run Linux containers only. Don't get confused. Got it clear, everyone? This is all running in a little Linux VM at the backend. Your Docker is installed on a Linux virtual machine at the backend. In Windows, you will see here itself, somewhere here, you will see an option to switch. Are we good and clear? So if you have installed Docker desktop on your Windows machine, you can use Docker on your local also. Not only on EC2, you can use Docker here as well. It's up to you. And these are all the images available. Am I clear with OS compatibility or any confusions? This is all additional part. If you are confused, just ignore it. Just learn this much you have to learn today. Like installing Docker and running the same hello world. Run command will search for the image locally. If it is not there, it will download from the hub and start a container. But pull command will just pull it from the hub. It will not start a container. That is the difference. Okay, do we need Docker install to execute Docker commands such as Docker? And of course, we need to install Docker. I just installed Docker here. Here, yum install Docker and start Docker. In Windows or in Mac also you should do. You can do it with a Docker desktop. Any more questions from anyone? We just saw the basic commands of pulling an image, running an image, and a container, but those containers are exited. So how to keep those containers up and running, isn't it? We have to keep them up and running. It's not that just you create them and leave them as is. We have to see our applications are up and running. So how to keep our containers up and running? What are the different modes of running them? How to search those images, pull the images, like container life cycle, all of those things we have to look into. So any more questions? Okay, is Docker, Podman are same? They are similar, but Docker is more widely used. Different containerization tool. Both are containerization tools. So this is all from my end. So if you want to use on a Linux VM, yes, you can get started it on one Linux machine, or you can also do hands-on on your laptop. You can choose the option. And tomorrow we'll deep dive into the hands-on, running different images, containers, container lifecycle, and so on. Any more queries from anyone? Any questions from the previous topics? Okay, a question from Prabhu. Docker on Mac only supports Linux containers, right? Correct. Correct, Prabhu. Because in Mac, you don't have an option to switch to Windows. Whereas if Docker desktop installed on Windows, you have an option to switch between Linux and Windows. Yes, please. Any questions from previous topics? You can go ahead. Do you want me to unmute you, Sarangi?
Hello.
Yes, hello.
Yeah. So actually, yesterday I tried with Jenkins,
Mm-hmm.
where I tried to push my work file to the Devops. I'm
Mm.
getting some issues where it's saying like uh, failed to execute goal organization Apache Maven plugin. There is some issue with the involved top level Maven targets. Actually, I checked. So let me share my screen. I don't have the option. Hello, am I audible?
Yes, you are.
Is there any option to share my screen?
Just a second. Give me a second. I think you can share now. Hello.
Yes. Is my screen visible?
No.
Not yet. Let me share. Can you check again?
Yes. No. Yes, I can see now.
So what happened? When I run my
Fail
this
to
job.
execute the goal.
Sorry, Preethi.
Go to the build configuration. -u deploy -a settings.xml. Go back. Go to the console output. Where are you running this job?
In Linux.
Scroll down. Compatibility issues. This is what I'm talking about. See, deploy plugin 3.1.2 deploy is not working. POM inside one more thing. Repository element was not specified in POM. You did not mention distribution manager element. See, one
Okay.
second. You read the error clearly. Repository element was not specified in POM inside distribution element. Have you added distribution management section in POM file?
Yes.
Show me. Go to your repository and show it. Go to the GitHub.
Okay. Uh, uh,
Added incorrectly. You added snapshot repository version. Open mine. Go to master branch. Here in the drop down, master is there. Go to master. Ah. Go to master. Go to the bottom.
mm,
See, this is how it should be. Repository element, not snapshot repository. You should go to your JFrog and get it from the release version, not the snapshot. Go to your JFrog, copying from the snapshot one. Select the release repo. Release. There will be something called demo one libs release local.
Yes, yes.
Store. Okay, set me up. Deploy. See here, this is how it will be. But you have copied something from the local snapshot repository.
Okay.
Okay, replace this one with the right distribution. That's what it was saying. Could not find
But
repository tag.
okay, got it.
You are not having that repository tag, rather you are having snapshot tag.
Correct,
Snapshot.
correct. Got it.
Correct it, and still if you have a problem, let me know.
Okay, sure.
All right, then that's all from my end. Good day. Bye, everyone. Thank you all.